Hello sir and my fellow batchmates. I am RAJORSI Sinharay from third year Electronics and Communication Engineering Department at Coochbehar Government Engineering College. Here is my CA1 presentation. The topic is pulse code modulation in the subject digital communication and stochastic. So let's start the topic. Pulse code modulation. Here is the introduction. Pulse code modulation, or in short PCM, is the name given to the class of baseband signals obtained from the quantized pulse amplitude modulated signals. By encoding each quantized sample into a digital word for baseband transmission, the code word bits are transformed to pulse waveforms. Definition. Here is the definition of pulse code modulation. Pulse code modulation, or PCM, is known as digital pulse modulation technique. In fact, pulse code modulation is quite complex compared to analog pulse modulation technique like PAM, PWM and PPM, in the sense that the message signal is subjected to a great number of operations. When pulse modulation is applied to a binary symbol, the resulting binary waveform is called a pulse code modulation waveform. Here is the key idea. The core concept of converting continuous time varying signal into a digital sequence that can be easily stored in memory devices, processed using computers or digital signal processors, transmitted over long distances without significant degenerations from noise. Now see the advantages that are associated with the PCM. High noise immunity, easy to process, secure, compatible with digital switching and networking. Now here is the main thing, most attractive thing, the block diagram of PCM. Here we can see easily the analog message signal is there, it's applied, which is passing through the low pass filter or anti-aliasing filter. Here if maximum frequency we can get out of the LPF. After sampling, it will be passed through quantizer, through binary encoder to parallel to serial converter to channel, serial to analog converter, decoder, reconstruction filter, and finally we get the reconstructed signal. These are three fundamental steps in PCM. They are mainly sampling, quantization and encoding. Now, need for PCM's fundamental steps. There are infinite number of amplitudes in continuous amplitude and continuous time signal. There is no such time interval when the amplitude of signal is defined, since time is continuous. It is due to these reasons we have to convert continuous time amplitude into discrete amplitude discrete time signal. Now the process sampling output is only available in integer multiple of TS. Here TS is the sampling time period. Since TS is constant, so the time axis of discrete time has variable n. Quantization. To discretize the amplitude, we use quantizer, which maps each sample to nearest available level. This is quantized level. The more is the quantization level, more is the accuracy of the signal. It is quite obvious. Quantizer can be broadly classified into two categories. One of them uniform quantizer and another one is non-uniform quantizer. Here is a quantizer division, like one of them is uniform quantizer and another one non-uniform quantizer. Further, uniform quantizer can be divided into two categories like mid-rise and mid-trade. Here we can clearly see the characteristics of mid-trade and mid-rise. Here is the input-output characteristics of mid-trade and mid-rise. It is said mid-trade because the origin lies in the middle of the trade of the staircase graph. as we can see very clearly. And similarly, the second graph, which we often call mid-rise, because in which origin lies in the middle of the rising part of the staircase like graph. So these are the two graphs. So now let's see the encoder. Encoder is a block that converts the quantized values into a binary code for digital transmission or storage. Each quantized level is assigned a unique binary number which represents the amplitude level, like sampler to quantizer to encoder. So now see the levels of quantizer. If the quantizer has 4 levels, encoder needs 2 bits for each level. If quantizer has 10 levels, encoder needs 4 bit for each level. So by observing these two examples, we can very clearly see that number of bits needed equals to log L to the base 2, where L is the levels of quantizer. Now it is quantization noise. Difference between actual sampled value and quantized value is called the quantization noise or quantization error. Now it is the formula epsilon equals to quantized sample minus original sample. The quantization step size. Here in the graph we can clearly see that the amplitude of the signal is xm. The maximum amplitude is positive xm and the minimum amplitude is negative xm. Here the formula of step size del is 2xm divided by q. Here 2xm is the peak to peak amplitude which is clearly seen here, and q is the number of levels. Therefore maximum quantization error, that is del divided by 2. The unit of quantization error is volt. Now see the uniform distribution of quantization error. For uniform quantization error is uniformly distributed in range minus del by 2 to positive del by 2. Here is the graph and the function which is shown here. It is a mathematical equation. So in the noise power, it is we assume that error is uniformly distributed. So from that assumption we can clearly see the v square of noise equals to del square divided by 12. Sorry, signal. Now let's see the signal to quantization noise power ratio, that is in short we call SQNR. So what is SQNR? SQNR is the ratio of signal power to the quantization noise power, P divided by del square upon 12. In earlier section we saw that the step size del equals to twice of xm divided by q. Now SQNR become that P upon 2 twice xm divided by q whole square whole divided by 12, which simplifies to 3pq square upon xm square. Now if we see the SQNR in terms of bits, it is like the derivation is q equals to 2 to the power v, and from that value SQNR become 3 into p into 2 to the power 2v upon xm square. So if we normalized this like xm equals to 1 and power less than equals to 1, the SQNR became 3 into 2 to the power 2v, and SQNR in dV is 10 log 10 3 into 2 to the power v, and which simplifies to 4.8 plus 6v in dV. So here is the all points associated with the PCM. So thank you everyone. Thank you.